Hey guys, welcome back to the garage. I'm working on the Emco Compact 5 lathe. It's been a little while since I've done a video, but I've actually been doing some work on it. Most of it's been having to do with the pulleys and the motors and getting them mounted up on the lathe itself. Got one of them taken care of, ran into a problem with another one, and I'll do a video and I'll recap what's going on with the motors and the pulleys and belts and so forth. I'm waiting on some parts, but in the meantime I decided to lay out the back panel, the electrical panel here, and I've got things mounted up. I've got the VFD mounted, I've got Acorn mounted, I've got the drives mounted. Gonna mount the power supplies. A couple things, I like using DIN rail whenever possible. Just makes things a little bit easier, and because the shallowness of the cabinet, I've gone with DIN rail power supplies. I've got a 24-volt power supply that'll take care of supplying power to the axis motors. I've got a 24-volt power supply for Acorn. I've got a 5-volt power supply for the logic signals to the drives. And so anyway, I decided to use those because they'll fit in the cabinet. I still have to space off the back panel off the back of the cabinet a little bit because this VFD is just a little bit too tall. I've got the Acorn mounted on the board. This is what I used. I used a little standoff, nylon standoff. I drilled holes in the back panel and then mounted them in the corners, and then Acorn just snapped right onto it. Bolted the VFD down. Of course, I used pop rivets on the DIN rail and used pop rivets on the Panduit wireway. This stuff can be bought from automationdirect.com. I'm sure Automation Direct has DIN rail if you want to use DIN rail. Emco.com sells DIN rail mounted power supplies, and of course Automation Technologies is where I got the closed loop drives and motors. A little bit about layout. I have another panel here. Basically this is another panel that I made, so in case I do another one of these I already have it all laid out. If you look here, I'm trying to keep AC stuff over to one side. I'm trying to keep the low voltage logic stuff over to the other side. I've got a stud here. This will be my common ground point. It means shields and grounds and everything will come to this point here. And there'll be one from here to the VFD. There'll be shields off these stepper driver control cables, which are going to be awfully short. Almost don't need them because Acorn is so close to them. But I'm going to run the drain wire over to this stud here as well, and if there are any others, they'll all come to this point. Basically what I did is I just kind of laid out the components. I kind of put the DIN rail together, put my power supplies together, figure out, you know, kind of how I want to do it. This is the first one. If I do any more, I'm fleshing everything out with this first machine. I've got this back panel for future machines. My idea was trying to put this together and package it up. If somebody wanted to buy a kit, I could pre-wire it all up. You just send me your, heck, you don't have to, well, there is going to be some modifications to the cabinet, I think, because we've got to get the stepper, we've got to get the axis motor cables into it. And you know, I think somebody could actually modify it. I have an idea. Centroid uses this strain relief that clamps up on the cables, and I'm thinking about doing that. But anyway, by doing this back panel, keeping the original, I used the original back plate for the Emco machine to locate all the mounting holes for it, so that I can mount it into the cabinet. And so that makes it easy where I can wire up this back panel out here on the bench, get everything pretty much wired up, except for things like the VFD motor. It's going to come through this little opening here. Note about these sheet metal. If you're drilling larger holes in sheet metal rather than drill bits, use these step drill bits. I use aluminum back panels when I can, and then I use these aluminum. I use these step drill bits. They're called unibits. That was the trade name. Irwin makes them now. You can buy them from a number of places. You can buy them from Amazon or whatever. But they're really good for sheet metal. They don't grab. You know, if you can, they actually will. they step down. So you start with a small hole and they work their way open, and then you can stop just short of the next hole and they'll actually kind of bevel your hole. So I go from the back side and the front side to bevel the hole. But the cable is going to come through this opening here, and then it'll land right here to T1, T2, T3 and ground. So that's what that hole's for, but I just wanted to share that with you. This is just aluminum DIN rail, so basically what's right here. You know, we've already bench tested this thing, so I don't know that it's very difficult to wire this thing up. It's going to take me several hours to do it, I think, and I'll be using a lot of video time. It makes it hard to edit. So what I'll do is I'll just I'll work for a little bit and I'll cut back in, explain what I've done, and then I'll cut out, I'll work for a little bit, come back in, explain what I've done. We wired everything up on the bench, so now it's the time is to, you know, is go ahead and permanently wire things up. I could have gone ahead and mounted all these components and kind of bench tested things, you know, you know, I chose not to do that because I hadn't figured out how I was going to lay out all these components. So anyway, I think that's about it as far as the component layout. And like I said, I'm trying to keep low voltage stuff on this side, trying to keep anything with AC on this side. In the back of the cabinet, there will be a fuse on this side, the power cord will come in on this side, and that fuse will fuse all this stuff. I've got to calculate the fuse size. It's going to be based on the VFD motor size. I'll probably take a current reading of all the logic power supplies and then decide what size fuse to put in it after that. Of course, when you're just kind of jogging motors around with no load, that's really not putting enough of a load on these stepper drives, the closed loop drives here. So I'll upsize it a little bit to take in consideration what the actual cutting load will be on everything. Same with the VFD and the motor. Motor's got a nameplate, so I'll go off of that. But anyway, the fuse and the cable will come in on this side. It'll feed the power to all this, and then of course all this is going to drop into the wireway and feed the individual devices. I already had a section of this. This is 1 inch by 1.5 inches wireway. I probably could have got by with 1 by 1, but I already had it. I decided to use it up. Just makes wiring a little bit neater. I'm not going to put wireway here. I think it's too tight. I'll just go up and land everything, go up, land everything, go up, and feed the drives and so forth, and maybe put a little tie wrap pad here and here just to kind of neaten things up. Needed to make sure I had enough clearance between this Ethernet jack and these components and the DIN rail so I could plug the Ethernet cable into the BeagleBone Green / Acorn. So anyway, with that, I'm going to go ahead and get started laying everything out. I've got a small relay. You might have heard me say in the video when I was bench testing this drive, I wasn't satisfied. It has an output for faults, and it appears that this thing is in a normal state. It would not trip if there was no power to this drive. So I'm putting in a relay so that when the drive is powered up, this relay will be closed and will not fault. But if the drive doesn't have power for some reason, the relay will open up and I'll have a spindle drive fault to Acorn, as well as the fault that comes out when there is a fault from an overload or something like that. But in its normal state, there's only one set of contacts, and I can't change the state of those contacts. It's kind of the caveat of an inexpensive drive, but it's not a deal breaker. A small relay like this is about 12 bucks, 15 bucks shipped or something. So we can make it work. So that's actually going to go down in here. These things just snap in. Same with the power supplies. They hook on and they snap down, and there you go. Put a little bit of space between them, but anyway, that's it. It's just a matter of start wiring things up. I will probably wire all the low voltage stuff, all the logic, all the power to all the drives, the Acorn and so forth, get that stuff done, and then I'll bring it back and kind of go over what I did, show you that. And the reason why I can't wire high voltage is because I've got to get, I might put pigtails actually from these power supplies and the VFD down to where the power is going to come into the cabinet. So I'll let you know here shortly when I cut back to the video and show you where I'm at, what I decided to do. Again, this is the first one. I'm hoping to do another one. This is just fleshing things out. It's kind of baking a cake. The recipe might change a little bit until you get it perfected, and that's what I'm trying to do. So we'll talk to you shortly. What I'm doing here is soldering pigtails to the drain wire so I can run them to the common ground point. These are the signal wires for the axis drives. Okay, and then what I do is I go ahead and put on a piece of heat shrink. I have this pencil torch. I set it relatively low, and then I just play the torch over the heat shrink here, taking care not to burn everything, especially the wire. And that dresses up the end, and now we've got the ground wire that's going to go down here to the terminal. One thing as you guys are going, make sure you tighten all your screws. When you're all done, go ahead and check all your screws to make sure they're all tight. It's bit me once before that that I didn't tighten down a screw, and it gave me a lot of grief. It was working, then it's not working, it's working, not working, and so forth. Also, these are really handy. These are wire ferrule crimpers, and I've got a selection of ferrules here. You can buy these in a kit form. You can buy the crimpers and the ferrules themselves on Amazon, less than 30 bucks, maybe 40 bucks, and they come in different sizes. I got 16 gauge, 22 gauge, 20, 18. I've just got an assortment of them right here. But when I can't use the ferrules, like what I had to jump, when I had to put two wires, the two 5-volt wires here in one connector, I use my soldering iron and I tin the end of the wire. So anyway, just kind of food for thought for you. These power supplies, by the way, are going to be connected together. The commons are going to be tied together. Obviously not the 5 volts and 24 volts, but the commons will be tied together because they need to be. Acorn is using them as a reference. One nice thing about using this wire way, you can kind of tuck back any excess. You don't have to spend a lot of time making sure all your wires are the same length. So it's worth. These are very inexpensive from Automation Direct. So I'd suggest that you you buy them, buy the wire way and use them. This is my 5-volt power supply. This happens to be a 3 amp 5 volt power supply. I didn't need 3 amps, but that's what I got it as. The 24 volts of 1 amp, more than enough for signal wiring and for Acorn. Not 100% sure I can get both of these ferrules in this power supply. I'm going to see. If not, I'm going to have to cut them off and tin them. Yeah, it looks like that's what I'm going to have to do. So I'm going to go ahead and do that to this one here. All right, let's see if we can get that in there now. Yep, slip right in. Make sure they both pinch well, because the ferrule's a little bigger than the 18 gauge wire, and I'm using 18 gauge wire as hookup wire, so. Make sure everything's snug. This is my 5 volt supply. It's 5 volts going up to the drives. The step positive, the direction positive, and the enable positive, then it jumps over and does the same thing to this drive here. So that's done. My power supplies, my 2 small power supplies are done now. I'm going to go ahead, I'm going to get some cable for the fault signals and get those wired up to Acorn. Okay, I've got my signals wired from the Acorn board to my Axis motor drives. Now I'm going to wire the power from the power supply for the drives. And one thing I want to point out is when you wire these, do not take one pair of wires from your power supply, run it over, run into one drive, and then jump over the other. You don't do that. If you have 3 drives, run 3 pair of wire from the power supply to your drives. All right, I'm going to go ahead and get that going. Want to make mention, this is the my wire from my power supply to my stepper drive. This is the power wire. I want to make mention that this is a 5-position connector. The motor wires go into this other side. Here it is here. So you see I had to disconnect them because these motors have to be routed around then fed in here. It actually would be nice if they do what they did here and put a 2-position terminal block for power and a 3-position terminal block for the motor, so that we can leave the terminal block on the motor. In any case, I just took a picture to make sure. I took a picture for reference so I knew which color motor wires went back into the connector, so I wanted to point that out to you guys. If you have to take your motor wires off, make sure you took a picture, or you draw a picture of the connector and then write down your color code. And these strippers, by the way, are the smaller gauge. It goes from 16 gauge up to 26 gauge wire. So these are Kleins. I don't see a part number on them, but you definitely want to get yourself a pair of these for smaller wire. Oh, and this screwdriver is also made by Klein. You can also find it on Amazon for about 12 bucks. It has a larger standard bit on one side, and then it has the small Phillips on one end, and then a smaller standard on one side. Same size Phillips bit that I can make out though. So very, very handy to have. Okay, so the drives are wired up to Acorn now. I'll dress all this up a little bit later after everything's run. Now I'm going to get a piece of cable that I use for VFDs. It's 18 gauge wire for the signals. I use 18 gauge wire. It's easier to use, and I feel better about using 18 gauge wire, especially on the analog spindle output. So I'm going to go ahead and start wiring that up. Just a little quickie on the wire that I use for the VFD. It is a shielded wire, 8 conductor. It's got a drain wire, and we'll take the drain on the other end back to ground, but it's a shielded cable for my VFD. I bought this stuff off of eBay. I don't know if the seller has any more, but 18 gauge stranded shielded wire is what you're looking for VFD connection. I think Centroid sells it as well if you want to buy it from them, by the foot perhaps, but it's what I use. So okay guys, welcome back. Well, I've got her all wired up. I got my power supplies wired up, VFD's wired up, everything's wired up, and I went ahead and put a jumper in because this is where I'm going to come off. I'm going to come off this power supply to a fuse and power in. I've got all my grounds terminated right here. So I wanted, before I really start tidying things up, I wanted to test it. Again, another bench test, basically just making sure that didn't do anything wrong when I was wiring it up, and to test my little relay here. You might see the LED on this relay. I'm using the 10 volts off the VFD to energize the coil on this relay. That way, if the VFD is not on for some reason, that relay will not get power, and it will close the contacts and send a fault to Acorn. So if it's not powered up, I'll get a fault. If the VFD itself faults, I'll get a fault. Here you see the green and blue wires, and they are paralleled on top of the green and blue wires here on the VFD. This is the fault output, so that if the VFD sends a signal to fault, it can fault it. Otherwise, if this relay de-energizes, it can fault and send a signal to Acorn. So I've gone ahead and powered up. I've got my motor wired up to the VFD. I've got a motor hooked up. I've got the other motor hooked up. It's actually on the lathe. You can't see it right now. And I've got CNC 12 powered up. So I'm going to do a reset on Acorn, and I'm going to go ahead and jog the x-axis. That's 100 inches a minute right there. And this is a 24 volt power supply. I don't know if you hear that. That's the z-axis on the lathe. Also 100 inches a minute. It looks pretty good. And let's try our spindle motor. I'm just going to flip it on here on slow speed. And I'll put 100%. And go all the way up. Okay guys, the last thing to test is the VFD. And I actually tested it, and something wasn't quite right. And I've kind of run into this before, and I've always been a proponent of grounding the shields of shielded cable. Well, this is a case where grounding wasn't a great idea, and I'll be able to recreate it and show you why. This green wire right here is the shield on this purple cable that feeds the signals to the VFD, okay? And if this little red wire, this jumper with the alligator clip, I had this terminated with the rest of the grounds over here. And actually one of the subscribers to my channel, I think his name's Tom Hutchins, mentioned to use shields grounding sparingly. Well, I'm not sure if this is the case or not. I'm not an EE, but I've always been told to ground all the shields of the low voltage cable. Well, anyway, so here it is. I've disconnected it. I've got this red jumper. It is connected right here, so we can kind of recreate things. First things first, let's hook it up and I'll show you what was going on. So I'm going to connect the ground. I'm basically grounding this shield back to the single point, okay? So I'm going to go ahead and start the motor here. So just listen and watch. Okay, that's supposed to be half speed. I'm at 100%, so I should be putting out 5 volts analog. This shouldn't say 9, it should say 30, okay? And then when I try and increase the speed, it actually came down. So I'm going to drop that back to 100. Now what I'm going to do is I'm going to disconnect the ground. And now it's running at 30 hertz, and that's half what I've got commanded. Now I'm going to go ahead and run it all the way up. So you can see, I mean, I tried a filter and the filter has no effect. You see a filter wired right here going in. That has no effect. I'm going to put all that back. It was this ground wire. So that's 5 volts. So the VFD is functioning fine now. The signal from Acorn is getting to the VFD just fine. We got 60 hertz. Anyway, this is a case where grounding that shield is not a good idea. So everything's working now. I will disconnect that shield. I will not terminate the shield from the VFD to ground. I'll leave that off because it's working there. That's about it. So this thing, I'm ready to tidy it up. I'm going to tidy it all up, bring it back one more time, let you see it all complete and cleaned up, that filter out of there, everything wired back up, and we'll test it one more time. Okay guys, just a final test. I'm going to jog the x-axis. Let's go fast. X minus, X plus, and Z minus. Z plus, start the spindle. That's full speed, half speed, and off. So it looks like everything's wired up, it's all cleaned up, it's ready to mount in the cabinet. I've got still the E-stop to hook up, that'll go in the cabinet, and then I've got the 2 Hall effect switches for the X and the Z axis. Alright, that's it for this video. Hope you found it useful, and I hope you found the little glitch with grounding the shield to the VFD signal cable interesting. I certainly did, and I got to thank Tom Hutchins, I believe it was, who brought that to my attention. All right, talk to you guys soon.